This video is on the 2015 AP Chemistry Free Response question number 2. In this long form question, you see that a reactant ethanol is being decomposed into a compound ethene and another compound water. The ethanol is placed over here on the left. Nicely, they give you the molar mass of both the ethanol and the ethene, so you don't have to go figure it out on your own. And what they're doing is they're collecting the ethene over water by displacement. Remember, the ethene is less dense and it's going to bubble up through here, okay, go through this tube essentially, bubble up through the water, and the water is going to go down while the gas goes up. Right? And a couple other things you notice when you read the question is they give you the volume of the collected gas, the pressure of the gas, and the temperature, which is basically screaming Pivnert, okay? But they also give you the vapor pressure of the water. So for those who've forgotten how this is done, right? Because the first question they ask you is, how many moles of gas are actually produced? Now, actually means how much product are you making, okay? And since they've given you this, and this, and you can always, obviously R is on the reference table, you can solve for the moles of the gas that's being produced. Just be careful about the pressure because some of the pressure, remember, some of the pressure total, which is what they're giving you, is the pressure of gas A plus the pressure of gas B. And gas B is water. Okay, so the pressure you want to put in there is not P total. You want to put the pressure of gas A, which is the ethene. All right, and to get that, you're going to have to move this around and subtract the pressure of the water. Now they give you the vapor pressure of the water, but they give it to you in torr. And so if you want to convert from torr into atmospheres, you have to remember that 760 torr is 1 atmosphere. So don't forget to do that conversion. And remember, if you subtract the pressure of the water from the total pressure, it gives you the pressure of the other gas, assuming there's only one other gas, which is the case here. Then it says, calculate how much would be produced if the reaction went to completion. What they're saying to you is, we know how much grams of this stuff we have, right? So here's what you're doing. You're really just calculating the moles of gas that were actually produced versus the moles that you would predict, right? Starting with your reactant amount, which is 0.20, and doing the stoichiometry here, which I'm not going to do for you, okay? But the good thing is it's a 1-to-1 mole ratio again, so they're making that question like really easy. If you know the moles of ethanol, you know the moles of ethene you were supposed to get. Now, the big picture is your actual yield should be less than the theoretical. So, and remember, if it's a percent, you're going to make it a fraction, and it's going to be times 100. So it's the part, okay, over the whole. In this case, it's the actual over what you theorize you should have gotten based upon the amount of reactant you started with, and you always times it by 100. I cannot tell you how many people forgot to put the times 100 when this original question was on the AP exam. It's not a fraction, it's a percent. All right. Then it says calculate, so that covers A and B. And then it says to you, do the thermodynamic data support the student's claim? Well, the student claimed that the reaction has an equilibrium constant of less than 1. Less than 1 means that you don't get a lot of reactant. If you get a lot of, look, this is not going to be on the exam, but essentially equilibrium constant, okay, at this given temperature, if you get a huge amount of product, remember it's product over reactant. If you get a lot of product, or most of the reactant turns into product. So if your actual yield is like 95% or something, all right, or the number of moles of ethene you get is much larger than the moles of ethanol that's left over, then you have a big value for K. And this means it's very thermodynamically favorable, okay? They want you to calculate delta G0 for the reaction. They're giving you delta S0 here. They're giving you delta H0, so you can use that as well to figure out what the value for delta G is. And remember, if delta G is negative, then K is a large number. All right, that last part C will not be on the AP exam, okay, but I figured I would go over it briefly. The Lewis electron dot diagram for C2H4 is shown below. Complete the diagram for this thing here. Now remember, carbons like to make 4 bonds. Oxygens like to make 2 bonds. Hydrogens like to make 1 bond. And they want you to draw it as pairs of electrons. Now, remember, none of these elements are below period 3. That means none of them are going to break the octet rule. All right? And as a general rule in organic molecules, things tend to do what they can do. They tend to do 4 bonds for carbon, 2 bonds for oxygen. That's a good general rule of thumb for an organic molecule. But you can try it out yourself by counting up the total valence electrons like you've been taught. It asks for the COH angle. Remember, this is a Lewis structure. Okay, it's not drawn in 3D, so it depends on how many. Like if this is what you end up drawing, this is what you end up getting. There's three regions around the oxygen where electrons are held. Then you're going to get an angle of 120. If you end up getting this, okay, it is 180. But just because it looks like it's 180 does not mean the angle is 180. Right? You have to use Vesper theory. How many electron domains are there around the oxygen atom that they're referring to? Okay, that is going to determine the overall bond angle within that molecule. I'm going to erase that. Okay, it says during the dehydration experiment, C2H4 and unreacted C2H5OH pass through a tube into the water. The C2H4 was quantitatively collected as a gas, but the unreacted C2H5OH was not. Explain this observation in terms of intermolecular forces between the water and each of the two gases. So this is talking about IMFs, and what they want you to see here is this. C2H4 looks pretty darn symmetric. And they want to see that alcohols always dissolve in water. That's when you buy alcohol dissolved in water. This is actually ethanol. This is the alcohol that's found in wine and vodka. It's always dissolved in water, right? So while some of the ethanol would have evaporated during the process, right, all the alcohol probably would end up dissolving in the water. Why? What is the IMF for something with this on it, with water? That's what it's referring to. All right? Whereas this looks pretty darn symmetrical to me, which means it's what type of molecule, right? So one of these is a polar molecule, one is a non-polar molecule. One of them is capable of hydrogen bonding as well, and one of them is not. And that's really the critical variable they're talking about in this question.